Okay, today we are going to start with the basic concepts of chemistry, that is mole concept. So before starting, you should have a background knowledge about the useful conversions. Most important, most widely used unit is 1 angstrom. 1 angstrom is equal to 10 to the power of minus 10 meters. 1 nanometer minus 9, 1 picometer minus 12 meter, 1 liter. This is where most of the people are mistaking 1 liter is not equal to 1 meter cube. 1 liter is equal to 1 decimeter cube. So if you want to convert it into the meter cube, then it is equal to 10 to the power of 1 liter is equal to 10 to the power of 3 minus 3, 10 to the power of minus 3 meter cube. Okay. This is useful and most mistaken conversion. And next one, most useful, and most of the people also know that 1 atmosphere is equal to 760 or torricelli. Okay. And if you want to convert into Pascal, 101325. But normally we will use it in the form of the bar only. So in 1 bar, Pascal and bar, when you convert it into the bar, then 1.013. 1.013 is the unit conversion. Okay. So 1.013 if you convert, then if you take into the Newton per meter square, then 1 bar is equal to 10 to the power of 5 Newton meter inverse 2 or 10 to the power of 5 Pascal. And 1 calorie is equal to 4.184, or normally people take it as 4.2 only. 1 electron volt equal to 1.6 into 10 to the power of minus 9 joules. And 1 joule is equal to 10 to the power of 7 ergs. And 1 calorie is equal to 1 joule, 1 calorie greater than 1 joule greater than 1 erg greater than 1 electron volts. The biggest unit for the energy is erg, second biggest unit is 1 joule, then third ergs, and lowest possible unit for the energy is electron volt. Okay, these are the most useful units for entire chemistry, not only in this chapter. Okay, now let us see about the molecular mass. Molecular mass is calculated by comparing with respect to carbon, and carbon mass is taken as 12 AMU. And when you compare with this, number of times its mass with the carbon, 1 by 12. Okay, because 1 by 12 is 1 AMU. So when you compare with the carbon, then you can write down in the AMU. And remember, AMU is always for one atom. Okay. So if I write 12 AMU means 1 carbon atom. But same thing if I write 12 grams, it is not 1 carbon atom, 1 carbon mole. 1 carbon mole means 6.02 into 10 to 022 into 10 to the power of 23. This is the small difference, but it is going to give you the different type of information. AMU is for one atom and AMU for one molecule if it is a molecular form. Second thing is if it is in the gram, it is always for the moles. It is always for the moles. Okay. That is the basic difference between the gram atomic mass and atomic mass. Okay. Then actual mass, see mass of one atom or one molecule in grams. So if I want to find out one molecule, then what I told you, that is 1 by 6.023. 12 divided by 6.022 into 10 to the power of 23. If you do this 1 by, if I divide, then I will get 12 into 1.6 into 10 to the power of minus 24. See, minus 24 is there. So that means mass of an atom is absolutely very small when I explain in terms of the grams. Okay. So next one is the same thing you can find out for the molecular mass also. So as I told here, when you write the grams, that is for 1 mole. Okay. So this is about the gram atomic mass, gram molecular mass, AMU. Okay. Now let us see about the next topic, mole conversion. Next topic is about the mole conversion. Okay. So 1 mole, when you want to convert into the molecule, then it is, if it is ionic, then we use a word called as a formula mass, okay? And if it is a molecule, gram molecule. If it is an atom, gram atomic mass, okay? 1 gram atomic mass for the atoms, for the atoms. 1 gram molecular mass for the molecules, for the molecules. 1 gram formula mass for the ions, if it is in the ions, okay? For example, if I take the sodium, okay, so you will get confused with this as a Avogadro number. So let me take as a potassium, okay? For potassium, I have to take the gram atomic mass. That is, its atomic number 19 and mass number 40. So this 40 grams is the gram atomic mass. Same way for oxygen, if I write the gram atomic mass, it is 32. Sorry, 16 is the gram atomic mass, and oxygen gram molecular mass, then it is going to be 32. That is the difference. Atomic mass, GAM of the oxygen is 16 gram, GMM of oxygen is 32 grams. And if I write the KCl, for this I have to use the gram formula mass, which is equal to mass of the K plus and mass of the Cl minus. That is the difference between the GFM, GAM and GMM. Okay, so next 1 mole of any substance, when you want to convert into the 1 mole of the substance, then we can have these many relation. When question is in the form of the number of, then this is the formula. When question is in the terms of the mass, this is the formula. And when question is in the form of the volume, this is the formula. 1 mole of any substance, irrespective of it is small or big, it is going to contain 6.022 into 10 to the power of 23. Okay. This mass is how much? 10 to the power of 23. If I say molecule, these many molecule. If I say atom, these many atoms. Okay. Number is fixed, but content will be keep on changing. Okay. Content will be keep on changing. Okay, so now let us see about the 1 mole. Again, I am writing here for clarity. 1 mole, when you want to convert into number of, it is always a fixed number, 6.022 into 10 to the power of 23. This is the formula for number of atoms, number of molecule, number of electron. But when you want to convert into the mass, either you have to take gram atomic mass, either you have to take gram molecular mass, or you have to take gram formula mass. Okay. These are all for the atoms, molecule, and ionic. Okay. And next one is for the volume. Volume is 22.4 liter. Mainly you should remember 22.4 liter. This is measured at STP. Again, this is constant. This is constant. There is no change. But these things will change from atom to atom. Like carbon, it is 12. Nitrogen, it is 14 for gram atomic mass. Same way molecular mass. It is nitrogen, it is 28 for molecular mass, 14 for atomic mass. Same way for ions also it will change. Okay. So when you are given with isotopes, and you have to find out the molecular mass average, then this is the formula we are going to use. Okay. So if they give, for example, chlorine, okay, chlorine is made up of the two isotopes, chlorine 35 and chlorine 37. Okay. So now if it is given that it is 75% of the chlorine is in 35 mass and 25% of chlorine is 37 mass, then average you have to find out. So 75 by 100 into 35 less 25 by 100 into 37 divided by total, that is 100. Okay, so like this you will find out the average molecular mass when same element exists in the terms of the different atomic mass. Okay, that is isotopes are given. Now let's see the next one. Okay, so here again, then when you are given with molecular formula and you have to find out the empirical formula. You should know that vapor density is equal to 2, vapor density is equal to molecular mass by 2. Otherwise, molecular mass is equal to 2 into vapor density. And relative density, actually, we will take the reference of the substance as a hydrogen. So hydrogen mass is 2. So that's why this 2 came here. So density of any substance is compared with the hydrogen. That's why this 2 is given here. So next, when you want to convert into the mass, this is the formula. When you want to convert into molarity, this is the formula. When you want to convert number of particles, this is the formula. When you want to convert the volume, this is the formula. Okay. So now how this formula came? Simple. Molarity is equal to number of moles by volume. Okay. So we can say that number of moles is equal to very simple molecular molarity into volume. So when you divide the moles by volume, you will get the molarity. When you multiply the molarity with volume, you will get the moles. So this is about the conversion of the moles into different forms. Okay. Next, let us see about the stoichiometric, okay, limiting reagent. So A, B, C, D represent a reaction is given. A reaction is given A moles of A react with B moles of B to form C moles of C and D moles of D. So A, B, C does not represent ratio of the masses. They are stoichiometric coefficient. That means moles they are representing. Okay. And out of that, how many moles of A reacted divided by A? So this is what called as a POAC, principle of atomic conservation. That is total mass reacted is equal to total mass formed. Total mass reacted is equal to total mass formed. Okay. So then when next comes the limiting reagent. For example, if I take the hydrogen and react it with the oxygen to form the water molecule, to form what molecules? Water molecule, then in this condition, so I have to use the 4 grams of hydrogen, then I have to use the 32 grams of oxygen. But if I am not able to use same amount, and let me take example as a 6 grams of hydrogen, but I am not able to take the more than 32 grams of oxygen. That time what happens? Reaction will stop as soon as 32 grams is consumed. This become as a 0, and by the time this 4 grams will be consumed, that means 2 grams will be extra. 2 grams will be what? Extra. So whichever is extra, that is called as a excess reagent, and whichever becomes 0 soon first, then that is called as a limiting reagent. That is called as what reagent? Limiting reagent. That is the difference between the limiting reagent and excess reagent. And sometime if I take, let us take another case. I have to take 4 grams of this, 32 grams of this. Okay. And by chance, if I am able to take only 3 grams, okay. So 4, and I have to take, I took 32 grams. So 4 grams require 32. So 3 gram does not require 32. So this will remain extra even after the reaction. This is consumed and become as a 0. In that condition, this is the limiting reagent and this is the excess reagent. So this is how you will identify the limiting reagent and excess reagent. Okay. Next, due to the problems in the experimental, the amount what we thought, that amount may not be formed. Okay. So that is the formula called as a percentage yield. Okay. Actually, what we get is different. What we think is different by calculation. That is, this is actual given and calculation given. So normally, either they will give you these two values and this you have to find out, or they will give you actual yield and percentage yield. Then you have to calculate the theoretical yield. Okay. So for example, percentage yield is 75%. and actual yield is 75 grams. Then theoretical yield will be 100 grams. So 100 grams is expected, but we got 75. That's why percentage yield is 75%. Okay. This is about the degree of percentage yield. Okay. Then degree of dissociation is how many moles are dissociated into further atoms. Okay. Then the formula is alpha is equal to M observed. MO means observed molar mass. Okay. And that is theoretical value. For example, if you take the N2O4, this calculated will be this one. And M is the molar mass after the reaction. Okay. After the reaction are at equilibrium, then N minus 1 divided by MO. Okay. So, sorry, M reaction. So N2O4 dissociate into 2NO2. This 2 is called as a N value. N value before taking, you should make sure that this is only 1 mole. 1 mole dissociate, then only this N value is taken. And for dissociation, N always greater than 1. Minimum it will be 2 only. Okay. So then we can find out the degree of dissociation. Clear? So let us see the next one. Percentage purity. Okay. So this is also again important for the stoichiometry. Percentage purity means here actual mass of the compound divided by total sample into 100. Actual mass of the compound divided by total mass of the sample into 100. Okay. So if you take the 100 grams of calcium carbonate, this is impure, but this is also called as a crude. Sometimes word they use is crude. Okay. So in that actual may be 93 grams and remaining 7 grams may be impurity. So 93 grams only react. Okay. So total mass is how much here? 100. Actual mass of the compound is 93. 93 by 100 into 100, that is percentage purity is 93%. Always remember inert and reactive material only taken as a impurity. Okay. So then for estimation, Liebig method is used for the carbon and its formula is for finding out the carbon percentage. Okay. So if you remember this as a simple method, 12 by 44. 12 is the carbon mass. In the 12 grams of carbon there, I can produce the 44 grams of CO2. CO2 molecular mass is how much? 44. That's why 12 by 44 into mass of the CO2 produced divided by mass of the organic sample taken into 100. This is how we can find out the carbon percentage. So if you understand this logic behind this formula, hydrogen is detected as H2O. So in place of the 12, how much it should be there? 2 hydrogen, 2 divided by. In place of the CO2, we have H2O, so divided by 18 into mass of the water formed divided by mass of the sample taken into 100. This is how we can find out the percentage of hydrogen. Okay. So when nitrogen is there, then we can find out the other method, that is Dumas method, Geldahl method. Okay. Nitrogen converting Dumas method. In this, nitrogen is converted, all the nitrogen is converted into N2. In the Geldahl method, all the nitrogen is converted into NH3. So here we will use the states of matter formula, that is PV is equal to nRT. So with that you can find out the mass of the nitrogen and substitute here, you will get the percentage of nitrogen. But for Geldahl method, given compound, nitrogen is converted into ammonia. But how much ammonia is formed? For that we will use the neutralization. Remember that this is a states of matter question, Dumas method, where nitrogen is converted to dinitrogen. In the Geldahl method, neutralization question, nitrogen is converted to ammonia. And formula for this is percentage of nitrogen is equal to molarity into volume into 2 into 14 by W. Okay. M is molarity, N is the nitrogen containing compound. Okay. So this is uh, some nitrogen containing compound does not give the above reaction. That is limitations of the Geldahl method. Okay. Next, if sulfur is there, it is converted into the sulfuric acid barium chloride. So sulfuric acid is transferred as a BaSO4. BaSO4 molecular mass is 233. How much of the barium collected is W1? So easiness, like I told you, sulfur mass is 33, 32. Its molecular mass 233 into mass of the barium sulfate we got divided by mass of the sample into 100. This is how we can find out the sulfur content in the given compound. Okay. So this is about the sulfur. Now let us see about the phosphorus. Okay. So phosphorus. So here phosphorus also same formula, it is collected as a Mg2P2O7. So here how many phosphorus are there? 2 phosphorus. So 2 into 31. How many phosphorus? 2 phosphorus. Phosphorus mass is 31. 2 into 31 by triple 2 into mass of the Mg2P2O7 divided by mass of the sample into 100. This is how we will calculate the mass percentage. So these are the methods used for the sulfur, phosphorus and all. And Carrier's method is used for the halogens. Okay. In this halogen, chlorine if it is available, yellow, white precipitate. Bromine available, yellow precipitate. Iodine available, bright precipitate, bright yellow precipitate. And here molecular mass of same formula, silver mass you will write here and divided by molecular weight, then you can find out the percentage of the halogen. Okay. When empirical formula converted into the molecular formula, N factor is used. Okay. And to find out the molecular mass, we may use some methods. That is, first method is called as a Dulong-Petit's law. First method is the Dulong-Petit's law. According to this, atomic weight of the metal into specific capacity, specific heat capacity, you will get the 6.4. So they will give you the specific heat capacity. With that, you can find out the atomic weight. Then to find out the molecular mass, Victor-Mayer method is used for calculation of the volatile compound. What compound? Volatile compound. Silver salt method is used like this. Organic acid and chloroplatinic salt method is used for the organic base. These are the some formulas related to the chloroplatinic salt, related to the acids, organic acid. This is related to the volatile compound. Volatile compound, Victor-Mayer method. Silver salt method is for the acids, organic acid, and for chloroplatinic salt of the method is for the organic base. So depend on the question to question, these formulas we have to revise and try to substitute in that. Okay. So next coming to the concentration terms. So these are the concentration terms, very easy. Percentage. So mass of the solute by mass of the solution into 100. So both are mass. That's why there is no units for this. Volume of solution is volume of solute by volume of solution. Mass volume means mass of solute, volume of solution. Parts per million. Same formula, but in place of the 100, here we will use the 10 to the power of 6. Mole fraction, moles of the given compound, total moles. And molarity, riti is there, moles of the solute by volume of solution in liter, volume of solution in liter. Then molality, see carefully observe, here volume is in liter for the solution. Here mass is taken in place of the solution, we will take solvent and in the kg. Okay. That is the difference between the molarity and molality. In the molality, there is a denominator difference. Okay. So next, mixing up the two solutions. So M1 V1 plus M2 V2 by V1 plus V2. And if you dilute them, M1 V1 plus V final molarity, V1 plus V2. After dilution, total volume. Okay. Then percentage volume strength of H2O2. Here, don't worry about all type of formulas. You just remember it as a 2 molarity is equal to 4 normality is equal to 6.8 percentage. Okay, otherwise strength 68 strength 68 gram per liter is equal to 22.4 volume. So this is the method you can find out all type of. If the volume strength is given, normality we have to find out. Then you will write like this: 22.4 volume is equal to 4 normality. For example, if they ask 4 volume, how much normality? If they give, for example, volume strength is given and you have to find out strength. So then you will write 68. So then 10 volume, how much is the strength? Like this, you can calculate. Okay. So this is about the special methods used only for the what? H2O2. And there is another substance, oleum. Another substance, oleum is there. So that oleum is 100 plus X. Okay. 100 plus X. So you can think that why it is 100% plus X means that extra, like here, they mentioned 109 gram. 109 gram means 9 gram of water required to convert the SO3 into the sulfuric acid. Okay, SO3 into the sulfuric acid. So you can check here, its mass is how much? 32 plus 48, 60, sorry, 80 grams. Okay, so 32 plus 48. 80 grams are required for 18 grams of water. 9 gram require how much? So 9 gram require how much? 40 grams. So that means 100 grams of the solution, 40 grams is the SO3, remaining 60 grams is the H2SO4. So like this, we can find out the percentage composition. Okay, this is called as the oleum method. Okay. It is again specially for the oleum only. Oleum is a mixture of H2SO4 and water. Okay. Next, eudiometry. In the eudiometry, how much gas is available? Gay-Lussac's law we can use. 1 mole of this react with 3 mole of this to form the 3 mole. Okay. Accordingly, we can find out the volume of unknown substances also. And we should not take the volume of solids or liquid because their value is negligible. Air is considered as a mixture of oxygen, nitrogen. So normally we will take 20% oxygen, 80% nitrogen for easy calculation. Nitrogen should be always treated as a non-reactive gases. But there are some cases like lithium and magnesium react, but in normal, in the eudiometry question, we take it as 0 only. Okay. So which substances absorb the which gases? Okay. Like KOH absorbs the CO2, SO2, Cl2. Actually, this is a base, so it will absorb the acidic gases. Ammonical cuprous chloride absorb the carbon monoxide. Turpentine oil absorb the oxygen. Pyrrolidol absorb the oxygen. So turpentine oil, ozone. And water is absorbed by the ammonia and HCl. CuSO4 also absorbed by the H2O. Okay, so this is dehydrated in converted into hydrated salt. Okay, so this is all about the complete revision of mole concept.